So we're starting with 14,000 of these organisms initially, and the number of organisms is growing by 7.4% each year. Now, before we get into the exponential function, let's just discuss what it means to grow by 7.4% each year. How many organisms would there be at the end of 1 year? Well, I have to take 0.074, that's 74% of 14,000, and add it on to the 14,000 that I started with. So there's what I would have at the end of 1 year. Another way to write that is to picture factoring out this 14,000 and what's left inside the parentheses is 0.074 plus 1, which is just 1.074. So another way to do this calculation is 14,000 multiplied by 1.074, giving us this number. Now, if I do the same thing for the second year, instead of going through this calculation, I can just multiply the new amount by 1.074 to get the 7.4% increase. There is what it looks like. So, understanding that exponential growth by a given percentage is 1 plus this number converted to a percentage. That's exponential growth. If we get into exponential decay, it's a little bit different. It's actually 1 minus that number. But so here's how we form the exponential function. Population, depending on t, this is the initial value. Here's that growth rate raised to the t power. Of course, when t is 0, this base to the 0 power is 1. 1 times 14,000, there's the initial value. After 1 year, we're just multiplying 14,000 times 1.074. And after 2 years, we're squaring 1.074 and multiplying it times 14,000, which is kind of what we did here. There's 2 of these factors of 1.074 times 14,000. And here's what the graph looks like, at least for the first 2 years. I'll paste it in on board 2. So there's the initial organism population, 14,000 at time 0, and it's growing exponentially. That's not a straight line. It's growing very rapidly. Okay, there you go. Hope that helped. If you have any questions, post a comment.